So let's get back to our Pong game and see if we can make use of inheritance and polymorphism to simplify our code, clean it up, make it easier to create robust and expressive game code. This is Pong CPP. We have our core loop with input, update, render, and a short delay. Our input method is nice. We're dealing with key events, mouse motion, and quit, but I'm pretty sure that the actual input methods are empty. On key up, listens for escape so we can get out of the game, but we don't care about key presses yet. I haven't made any input here. We might leave that for you to implement for the final assignment, right? Now we have update and we have render, where we have to step through every single entity in the game, the left paddle, the right paddle, and the ball, to update them separately and render them separately. And this is exactly what I want to get rid of. What I want to be able to do is put all entities in a list and then just update the list and render the list instead of dealing with them separately. That would allow us to create new types of entities and just generally make much more engaging games, right? If we go to the Pong header, we see that left paddle and right paddle are both of type paddle, and the ball is a specific type of its own. So a naive solution, which is not a solution at all, is to say bring in the vector class and then create a standard vector of type paddle, and then put both paddles on a list, and that way we have gotten rid of, well, at least these two specific ones. We can update any number of paddles this way. But of course, that's not flexible enough. We want to be able to put a parent class of all of these objects into a list, and then use polymorphism to update each specific object correctly. So the way we define or create the base class is look at the specific types we have and figure out what they have in common. So the ball has a rectangle, colors, velocity, x and y, and then methods for getting those values. It has an update, a render, and a way of setting velocity. My paddle, wherever that might be, there's CPP, here's the header. The paddle header is nearly identical, except for the fact that it doesn't have a Vx, doesn't have velocity on the x-axis. So what I'm going to do is create a parent class that holds everything these classes have in common. And to make my life easier, I will just make them identical, right? The paddle will have velocity x because it doesn't really hurt us. So I'm going to make the ball, or the code we've written for the ball, the basis for our entity class. So if I create a new class, I make this entity. No base class needs to be filled in here, but virtual destructor is nice because these methods are going to be virtual anyway. You don't have to check this. It's easy enough to make on your own, obviously. Here we go. Interestingly, that wasn't declared. Let me save there. Let me go over here. It was not declared virtual. How does that happen? So we can do that. Now, let's start with copying over the interface from the ball. So I go to ball H. I want to grab these functions. Just bring them over to entity H. So that's set velocity, update render, and then the getters for all the stuff we need to get. I need to bring in the renderer. I wish there was a quick fix. I'm pretty sure there is. Well, whatever. We include the renderer, because that needs to exist here. Go back to, let me close down some stuff. Don't need that. In fact, I don't need all but this. And then we can open entity again. There we go. I want the private members to be part of the parent class as well. So we make every entity has a rectangle, a color, a velocity. And the rectangle doubles for position, right? This is the X and Y value. Now size we don't have here, so I'm going to just make it a 0 size in the base class. So the base class has no shape, no position. Well, it has a position, but it's a bad one. It's top left corner. And 0 velocities. It is by default full white. That's fine. And I think this is all we need to leave in our ball. Do I need to bring this over? No. So we go to the implementation of the ball, and we're going to grab all the methods that we have to implement in our parent. Take these. That's everything but the constructor and destructor. Go to the entity, entity CPP. This is constructor, this is destructor, this is the implementation from the ball, and then we go through and just update the scope. So we are defining the methods in the right class. Make them entity get width, entity get height. Make sure that that's height width yx. Yeah, that's correct. So far, so good. Now, the first thing the render call does is set a color and then fill the rectangle in. On the render we passed, that's nice. Update does what we expect it to. Set velocity does what it expects us. What we expect it to do, rather. Do I need to do anything else? Yes. Our ball, being a child class, it's not actually a child class. It doesn't actually have access to the rectangle at all. So we need to make the ball a child class of entity. And so you know how to do that. We declare our class here. I'm going to remove the includes we don't need anymore. That is all of them. So our class is named ball, and it inherits publicly from entity. This means ball is an entity. We need to include entity. There we go. Ball is an entity. That is all. Now, ball should still not have access to the rectangle because that's the superclass private property. If we want to make these private values available to the base class, to the child class rather, we can make these properties protected. Protected means that they are private to this class and all its child classes. So now ball can write to the rectangle. That's convenient, but it's not the cleanest way. It's not the best approach for a robust object-oriented system. You generally want your class, the entity in this case, to be able to protect itself from abuse. So a better way is to create setters for all the values. So if I do these again, should I do set? I can make a specific setter for each value, or I can make one that does them all. Let's do one for each. So we do set x, set y, set width, set height. All of them takes an int value, like that. And then we can do the quick create definitions, escape, control, full stop, create definition, escape, control, full stop, create definition, escape, create, full stop, and escape. So we have 4 new methods. They're empty, but they're public, so we can reach them from the ball, right? Let's actually implement them first. If I go to the CPP of entity, here are the setters. Oh, whoa, I declared them the wrong. We need to go back here. They should not be returning values. These are setters. They should be void methods. There we go. And these should be const. They are getters. You know, let's be proper when we can. So we make all of those const, we make all of those void, which means I have to go back to the CPP and make void, make this setter void, make this setter void, and make this setter void. Go up to the getters, make that const, make that const, make that const, make that const. And now a void function can't return anything, but we have been given a value, and this is set y, so that would be rect y equals y. Obviously, the benefit of having a method like this is that you can do some error checking. So that's v. If you want to, you could log here, you could check that the value is something reasonable, that makes sense for your game, whatever you need really. But for now, they're just going to be an implementation feature. So this is width, this is height. And again, just because there's more syntax doesn't mean that the code is any slower. The compiler is very good at optimizing stuff like this, so it will be fast even if you go through this public interface. Having 4 functions for these values might be overkill. Frequently, we want to set all values at once, so we can make one final change by adding a void setRect, which will take 4 values, right? An x, y, width, and height. Height and width? I'm not sure. Which order is it? Peak definition? No. Peak. That's, oh, sorry. I'm doing on the object instead of the type. Peak definition, width and height. Width and height. Width and height. Yes. So that's a set rectangle, which then of course just calls these other methods. You could also have an override of this that takes an SDL rect and copies the values over, but you know, we don't really have need for that now, so let's not bother with it. KO, implement this, quick actions, create definition. There we go. Set X of the rectangle should be set X. Close that, close that, close that, close that. And our set rect here, we could obviously do rect x equals x and continue on for all of these different values, or we can make use of the functions we just wrote, like so. Set x, set y, set width, and set height. And again, this method could do some checking, like make sure that width and height are not negative. And if they are, this is set width. And if they are negative, you know, throw an exception or assert. In fact, let's make an assert. So SDL assert. I don't think I have SDL included in my entity, so I'm going to just bring it in here. SDL system is nice because that brings in SDL for me. Let's see. SDL assert that W, that is width, is more than 0 and height is more than 0. So now we can have a way of catching programmer errors here. You should probably have this assert in these specific function to be, you know, entirely safe. But now in our ball, what we do is set rect. So you're calling the method in our base class, passing in x, y, and then I want width and height. So this would be, actually that's the x and width. I want that math. Okay, to make this clearer, let's do x. What should I call it? My x? Yeah, my x, that's fine. My y, man, that's a bad variable name. And then we pass in ball size, ball size. All right, messy, but not too messy. So we have a way of setting the rectangle from the constructor of our ball. Our ball is an entity, which means we should be able to set up a list of entities for balls at this point. I need to do the same thing for our paddle, but it should be easier because the paddle has all the same features. So in fact, I can just copy these calls, go to our paddle CPP, then open the header, delete all the private members. We don't need them. They're from the parent class now. We don't need velocity update, render, get x, get y, get width or height. None of those. Go to the CPP, remove all the functions I just undeclared. Again, we will rely on the implementation from the parent class. Our constructor makes use of setRect in the parent class, which means I have to bring that in. What was the size? Ah, right. It had a pre-declared thing there I have to figure out. So for now, I'm going to just hard code that value. No, in fact, I won't. Let's get back to header, make paddle a child of entity. which means include entity. And let's make a public static const width and a static const height. Oh yeah, a type is good to have as well. So we made it a child class. We declared some constants. Go back to constructor, make use of those constructs. So this should be paddle width divided by 2, paddle height divided by 2, and then we pass those in as there we go. And so you notice whenever I type, right, get x, this is from our parent class, set x, also from our parent class, but they're available here, they're public. And we've got them because we are a child class. And now our pong.cpp, pong header, I think we should take a break, but we can convert all of these into a vector of pointers to entities, and then have our core loop deal with entities instead of specific stuff. Let me actually just recompile and see if this still works. No, it can't work because we have not made virtual functions in the entity, have we? No, we need to make set velocity, update, render. Actually, none of these probably need to be because they are not overridden anywhere yet, but whatever. Make them virtual. Set velocity don't need to be virtual. Update and render are the stuff we care about changing in the subclasses if anything is going to change. We compile and see what errors we got. That's a fail on paddle uses private. Did I mistype that? Paddle H needs to do a public inheritance. A private inheritance is of no use. So make that public, otherwise those are not available from the outside. And there we go. So the only thing we've done so far is reduce redundancies. Right, everything that was in the specific classes are now in the parent class. We should make the parent constructor protected so that it can only be used by child classes. We can do this. This prevents us from creating an entity. The only thing that can create an entity are child classes. So this means only child classes gets made. So that still works. That's a good little safekeeping trick there. But yeah, let's create the list and update our core loop in the next video.